Hello everyone, we are from Group 12, and today we will present our computational thinking case study 2, which is the automatic battery charging protection system. Our group now, members are me, and Brian Sultana Bagasmati, Eric Klaus Williams, and Satria Hidayah Rafid. The problem we are solving involves with rechargeable batteries used in laboratory devices. During charging, battery may experience overcharging or overheating, which can damage the battery, reduce its lifespan, and create risk. Because of that, we designed an automatic battery charging protection system.
Okay, so the objectives of this system is to automatically manage batteries charging safely and efficiently. Specifically, the system must prevent overcharging, prevent overheating, stop charging when the battery becomes full, and to resume charging when conditions become safe again, and to provide clear monitoring information to users.
To solve this problem, we applied computational thinking principles, which is decomposition, pattern recognition, abstraction, then the algorithm. First up is the decomposition. We broke the problem into smaller subproblems such as monitoring the battery voltage, monitoring temperature, determining charging status, stop charging under unsafe conditions, resuming charging when it's safe, calculating remaining charging time, and displaying charging information. Second one, pattern recognition. We identify repeated monitoring and repeated decision making as the main patterns in the system. Third one is abstraction. We only focused on important variables such as the battery's voltage, the battery's temperature, the charging rate, charging status, and safety thresholds, while ignoring unnecessary details like the battery's brand or the chemistry.
Okay. After building the conceptual solution, using computational thinking, we translated the design into a Python implementation using Google Colab. Now we will explain the actual program, and we have a division of contribution here. Jonathan, Brian, and Ryan Klaus have their own contribution to this code. So, Jonathan, let's do the first part.
Uh, so the first one, I will explain the object-oriented structure of our program. We choose object-oriented programming because the battery charging system can naturally be represented as an object with its own data and behavior. We created a class called battery charger. Inside the instructor or init method, we initialize the main attribute needed by the system. Like maximum voltage, maximum temperature, charging rate, current battery voltage, charging status, and a history list. The history list is important because dynamically stores monitoring data from each charging cycle. The structure keeps our program modular and organized.
Okay, so the next one is I will explain the core charging logic inside the check battery method. So this method evaluates battery conditions during every charging cycle. Okay, so first one, the program checks whether the battery voltage has reached the maximum voltage. If yes, the charging status become off because the battery is full. And if the battery is not yet full, the program checks the temperature of the phone. And if the temperature exceeds the maximum safe limit, charging status also becomes off because the battery is overheating. If both conditions are safe, charging remains on. And when charging is on, the battery voltage increases according to the charging rate. And we also added protection so that if voltage exceeds the maximum safe limit after charging, it is automatically kept back to the maximum voltage. So this ensures safe charging behavior.
Next up, I will explain the monitoring calculations and the output system. After checking the battery's condition, the program then calculates battery percentage by dividing current voltage by the max voltage and multiplying it by 100. Then the program calculates the remaining charging time. If the battery is already full, remaining time becomes 0. Otherwise, the program calculates the remaining voltage needed divided by charging rate. All monitoring results are stored dynamically inside the history list, and each record stores recycle number, voltage, battery's percentage, temperature, charging status, remaining time, and the decision reason. Finally, the show report method formats all stored data into a structured table for easier monitoring.
Okay, now I'm going to explain the main execution flow. So the program starts by asking the user to input maximum battery voltage, maximum safe temperature, charging rate, starting battery voltage, and the maximum monitoring cycles that we could put. And after receiving these inputs, the program creates the battery charger object. Then the charging simulation begins using a while loop. That loop continues while the battery is not full and then while the monitoring cycle limit has not been reached. And during each cycle, the user enters the current temperature, which kind of resembles a sensor. And then the program is called check battery method. If the battery becomes too low, charging becomes off, meaning the voltage does not increase. However, the simulation continues. If the next cycle has a safe temperature, the charging automatically resumes. This matches the case requirement for a safe restart after overheating. For demonstration, in here we use the 4.2 volt in maximum voltage, 45 degrees Celsius in maximum temperature, with 0.5 volts per hour in charging rate. Then we start at 1.8 volts. And the simulation shows that the battery progresses cycle by cycle until it reaches the full charge. And at the end, the charging report table displays all the monitoring history clearly. And through this implementation, our solution fulfills the required programming components, including the output conditionals, looping function, and dynamic data structures, and also including the object-oriented programming. Okay, thank you. Probably that's all that our group have to say. So yeah, thank you for listening.